Today we're going to be discussing the principle of the conservation of momentum. This ties in closely with the principle of the conservation of energy. Specifically, we're going to be looking at a perfectly inelastic collision in between two train cars. In our scenario, we have a train car with mass equal to m rolling down the track at 20 meters per second. In front of it is another train car rolling slower. Its mass is 2m, or double the mass of the first train car. However, it's rolling half as fast, only 10 meters per second. What happens whenever the first train car actually couples with the second train car? Well, the overall mass of the new composite unit is going to be 3m, but what is our velocity going to be? Well, we're going to use the principle of the conservation of momentum to figure that out. Momentum is normally defined by the variable p, and it's going to be equal to an object's mass times its velocity. Now, the principle of the conservation of momentum states that the overall momentum inside of the system must remain constant. So therefore, P1 plus P2 has to equal P3. In this case, our P1 is our first car, P2 is our second car, and P3 is our composite unit. So therefore, M1V1 plus M2V2 equals M1 plus M2 times V3, with M3 being M1 plus M2. So let's go ahead and plug in our values. So therefore we have M times 20 plus 2M times 10 equals 3M times V3. So therefore we have 20m plus 20m equals 3m times V3. So that gives us 40m equals 3m times V3. Therefore V3 is going to be equal 40m over 3m. 3m's will cancel, so therefore V3 is simply equal to 40 over 3 meters per second. Now, we can simplify that down further and make it into usable numbers, which is equal to 13 1/3 meters per second.